So our next speaker is Ladislav from Syoncloud.
Hello. So I would like to talk a little bit about big data in finance industry, and essentially it's more specific. It's big data investment banking for calculating risk exposure. So essentially, investment banks needs up-to-date information about their risk exposure. The risk measures are calculated from market fluctuation during certain time periods and existing positions. Well, the most important measure is the value at risk. So if an exposure to certain risk is too high, traders need to try hedge their position by buying futures, selling certain shares, and so on. So relational databases are not very good and efficient to deal with the aggregated data. We have existing systems that are specific to certain market area or specific to a certain organization within a bank, and they try to and develop their own standards. So the current situation is basically that risk measures per trade or per position are calculated based on the market data in the trading systems, which is quite easy. And aggregated risks are calculated in risk management systems. These systems rely on daily imports of trades and market data. And this leads to incomplete and stale picture of aggregated risks. Because all these exports take certain time to be processed, and currently the work has been done by a team about 70 people who took the exported data from these 56 various market systems and risk systems and sort of massage the data in order to get the aggregate values. And so the data with aggregated risks per certain books or per flow were available day after, and they were essentially stale. So risk management teams needs to see up-to-date and complete picture of risk in order to make right decisions. So risk management systems needs to be able to drill down into the aggregated risk and see all these components and then make a decision based on this. So it has to drill down through this various aggregation level to the book and to the specific positions. So there are currently multiple risk management systems that calculate different risk values. Well, the traditional approach was essentially to create a data warehouse that has a specific format. But the issue was that each of these risk systems has different formats that are changing. So when we create such data mining, data silo, we will face the changes that we need to do to the actual data. It meant ETL process, essentially extract, transform, and load for each risk system and each data format. These warehouse databases were optimized for reads of unchanged data. But we are in different position because we know that we will recalculate the aggregated risk based on the most recent market data, and so these data are not static. So then the data needs to be optimized for not only for reads but for the writes as well. So we see that there are issues with the traditional model. We need to deal with the gaps with aggregated risk data and measures, and data is recalculated and continuously replaced with more recent values. So we miss here the flexibility because the import formats can change. We miss the scalability because obviously in order to process that large amount of data, it's about 50 gigabytes of risk data a day. It's in 20,000 comma separated value files. It in together is 1,600 different formats and flavors of those formats. That's just per day. So what we had to do, firstly, we took a look at the data what we had. We used open source software that was available as a Hadoop and a PIC language. And we processed the data and look for the headers of those CSV files, and we look for the commonalities. Then we analyze essentially names of these fields. And when we created automatic script that was able to gather this information and change order of all these fields, and it was one part of this processing. This was a processing on the file level, and we utilized the information that the name of the system and the date and time was coded inside the name of those files. So we have analyzed these formats and exploited all these commonalities. So why is such a diversity in the formats in one organization? What are the differences? Well, there are different field names, there are different formats of the data, and so on. So we used essentially globs and regex in order to get this information into HDFS, and we used Apache Uzi to run the specific scripts and process this data. We try to create each of those scripts and each of those MapReduce very specifically, and we join them together in order to process these data. So we try to reduce this var area of formats into the groups and then the subgroups. And once we are able to process it in these groups, we are able to export it into the HBase and run the quality check, so run what values are missing, and we are able to recalculate these values. On top of it, there is a web user interface, existing one, that essentially enables to query HBase for these aggregate data. In the same time, it's able to drill down to the more specific components of the risk. So, essentially, this is the basic of our problem we had to solve. And I would say it would be very hard to solve it with a relational database, because we would have to force ourselves, to create a common format, which was very hard to do. And when the new data comes into such system, we would have to accommodate it through changing the schema of our relational database. So we avoided this change by storing this data in partially structured format in a Hadoop and in the PIC stores that can be processed much easier. So instead of changing stored data, We just change those scripts that extract the data out of it. So these are essentially the way how we execute these scripts. These were executed through the UZI, which included a schema, execution schema. So we know which script is executed. Only after it's finished, another script will take these values and move to the next step. During all the computation transformation, we had to skip incomplete and faulty records, eliminate duplicates, calculate IDs, because even though we have some trade ID or TCN that are unique for that specific application, they are repeated in different systems. So we have to create trade ID that is unique across the whole bank, for example. That can be done, that can be composed from the name of the system, from the internal ID, and so on. All right, so now I'm ready for questions.
So what organization did you do this for? What bank did you?
So this is done for the Credit Suisse.
Okay, but you own this product or this process?
It's not a product, it's a part of the risk management process as part of a larger project. And essentially this solves the problem, because before that the whole process was first thought impossible, because there was so many different systems and so many different types of the files that they initially thought, oh, we would have to come and integrate, create some adapters for each of those systems. Or we would have to go inside of these databases and then extract the data out of it. That was impossible, because when you look in one of these systems, they have thousands of tables. It's a relational systems, and it's not like you have a name of the field called TCN, trade ID. There was a name like field 1, and then you have another table inside you were written, okay, trade 1 means TCN. So it's a very complex structure. So we let them be without any change. Tell them you don't have to change anything. Just export your data in denormalized form. So try to write, instead of ID of the customer, try to put his name there. And then we would be able to process it and match it with the data from the other system.
Are you planning on turning this into a product or into something that you sell to other people?
It's really based on open source software, and we were very flexible. So we used the simplest thing what was possible. So, for example, we use Hadoop from the Apache. We use Pig. We use UZI to run it in HBase. But in the same time, we can use a different NoSQL database, which will do the same. And I know that now part of the project is Vertica as well. Vertica is not open source, it's very expensive, but it has certain advantages because it enables you to query the system in a SQL language. But there are some issues with scalability, so it's good for certain part of this project, not for all.
Thank you.
You're welcome.
Hi, I'm interested whether you're using lazy evaluation. So are you providing consolidated value at risk so that you only provide, do you do the calculations in order to provide a user an answer, or do you do the calculations every time more data comes in?
You have to do it every time, because you need, as the queries are queried through the user system. So you need to have these aggregate values already prepared, and you have to have inside one record. For example, if you use this NoSQL database, it's not a relational database, so you don't have like a foreign keys, but you store the keys for, let's say, the share data inside the same row in the different columns. So that's what you do. So you have to get the data out of that way.
Are you getting the CSVs intraday or overnight?
This is done online all the time. So before that, it was done overnight, and this is slow. And there was a manual involvement as well of the people of the team that actually processed the data. So we try to get the data as soon as they are available. So if you can imagine, it's a directory. When you get 50 gigabytes of data during a day, it comes when it comes. And sometimes you have already pre-calculated risk data in it, but they are different from the current ones. So these NoSQL databases are very good because it lets you store a new value onto the position the old one, and you still have inside the older values. But on the top is the newest one. So once you do calculation again, you will get the most recent value. And again, sometimes you don't get value at risk, but you get another information. For example, information about the trades. So you can calculate a histogram for three months for the value of the share, and then you calculate the value at risk by yourself. But the idea was, if it's available somewhere, why you would have to calculate it again? Just pick it up. If it's stale value, or if it's missing, then you recalculate it. Once the user asks for it, if it's not there, you have to calculate it. But most of the time it's already fixed, because you run quality checks on the data, and then you mark if there are certain data are missing, and then you run another process on top of it, and you recalculate those missing data. So you are trying to keep up-to-date picture as much as possible.
Hi, so you're offering this kind of near real-time VAR for Credit Suisse. Are you tied into Credit Suisse, or can you offer this to other capital market institutions?
This is available. It's a part of the project, and it can be offered for other customers as well. And obviously, it would be different, because each of those customers, they have a different input data, different standards, different formats. So it's not a package that can be installed somewhere and it will work. But the process is, you will look for the data that are available. You might use the export capabilities of those market systems. Sometimes they provide exports in CSV formats, or in text formats, and so on, because you don't want to change those systems. You just want to use them in terms of source of the data. And only after you get, let's say, first batch of data from the systems, you run some analysis on it, which can be done in a couple of days. And you can see, are we able to calculate this value, or are we able to get this information out of this particular batch of data? When we see we can, then we can create a system that will work, that will work and will be able to process the data continuously, and will be able to get you this information that you ask for.
So you're seeing a lot of interest then from hedge funds, sell side?
We work on similar projects that were not related to the banking. So this one was really a major client. There is interest in terms of using it, but I would rather speak with all those people who would like to have this kind of system and really try at least some pilot on the data what they have available, so they can see it by themselves. I think it's much better, because we are not trying to force certain solution. We are trying to use all these systems in terms of NoSQL databases or Hadoop in order to solve that specific problem.
Thank you very much, Ladislav.
You're welcome.